Alright, properties of exponents. There's basically 4 properties of exponents. Whenever you have the same base, see they're both a, but you have different exponents, the simple property is what you do is you add the exponents. So if the bases are the same, you can, and the exponents, you can just add the exponents. Here, when you take something to a power to another power, basically you're powering a power, you multiply the exponents. When you're taking two things, 2, 3, however many things inside of here, to a power, what you're doing is you're distributing this power to both pieces. So it basically becomes a to the n times b to the n. That n goes to both pieces. And anything to the 0 is 1. Those are your 4 building blocks. Okay? And you got to just memorize those. There are shortcuts, which I'm going to talk about, and it kind of can make sense of why they do what they do. Anywho, for number 1, if I have x to the third times x squared, which of these properties is it? It's the first one. Same bases, different exponents. Your answer is simply x to the 3 plus 2. You're just going to add the powers, which that would be x to the 5th. Now, if you want to see this visually, x to the third is this. X squared is this. How many x's do you have? 5. Isn't this x to the 5th? X times x times x, 5 times. So if you want to draw it all out, you can, but it's a lot easier just to add the powers. Hopefully you can get to the point of just adding powers. Number 2. Now, this is very similar to this one, except you have 3 pieces in each parenthesis. So all you do for this particular problem is you multiply. This right here is everything in these two, and everything here is multiplied together. So all we're going to do is multiply this times this to start with. And when you multiply this times this, you get negative 30. Then we multiply the x's. Deja vu. X to the third, x squared. Deja vu. There it is. Wouldn't that be x to the 3 plus 2? Aren't you going to add those two, which is going to be 5? And the last one, if you multiply the y's, do you guys understand there's a y to the first there? So when you add 1 plus 7, you're going to have y to the 1 plus 7. And your final answer ends up being negative 30, x to the 5th, y to the 8th. So you add the powers, and you're done. Now, you could technically put 3 x's, x, 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 y, be the 6, x, x, and then 7 y's, and then sit there and combine them all. That's a pain. It's a lot easier just to add the exponents. Number 4. I skipped 3, so notice that, sorry. But number 4 looks a lot like this one right here. A power to a power. So x squared to the third, all you're going to do here is go 2 times 3, which would be x to the 6th. Now, if you can't remember that you're supposed to take a power to a power means multiply, here's what you do. Do you understand x squared to the third means x squared times x squared times x squared? Now, go back to this property. Doesn't that mean add these up? 2 plus 2 plus 2, isn't that 6? There is another way of doing it for those of you who can't remember to multiply or you struggle mixing them up. Just write it out. Write out what it says and you will remember what you're supposed to do. Look at this one. This is kind of like this one and this one morphed together. So the first step in doing this one is, first of all, could I put parentheses around this right here? If you wanted to? Yeah. Now, can I take care of these two together? What's that going to be? Is that 7 or 10? Hopefully you notice that's 10. So it's going to be 3x to the 7th times, you're going to multiply these two. Isn't that x to the 10th? Now, looking at these two, aren't these x's going to combine when you multiply those? The 3 stays. And once you, what do you do with these powers? You add them, subtract them, multiply. Hopefully you realize you add those. So it's going to be 3x to the 17th.